you're going to learn to like underline the key information. So 35 liters. Right? And then we read that the bucket springs a leak, right? And we start losing 1 liter per hour. That word per, this is important. Okay? We want to write an equation that represents this situation. Okay, so let's define. We can say let L represent the, and maybe, you know what, I'll scoot down here, guys, so we have more room. 1. Let's say let L represent the amount of water okay, and let's say T represents the amount of time. In hours. Okay? And so what you're going to do is you're going to try to represent this situation using an equation. Okay? And I think the easiest thing that I can think of, forget about this down here for a sec. We're just writing the equation. This is step 1. Okay? So I'm going to write an equation using the variables that I've defined, right? You can pick whatever you want for these. It doesn't have to be L and T. Right? Could be V for volume, right? Whatever. The point is we're going to write, all right, our equation needs to tell us how much water is in this bucket. So, L equals, okay? Now, it tells us how much water was in it at the very beginning. This sounds like a starting value. Right? So we go, okay, the starting value. Well, if I write out y equals mx plus b, we know the starting value is here on the end. So I'm going to have something plus 35 because that's where I start. Okay? Then I'm like, okay, that takes care of that, where I start. And the second part of this tells me how the graph is going to change. Right? Or how is this situation changing? This word per, I always associate with the slope. Kilometers per hour, for instance. Slope. It's a rate of change. Right? So we're losing 1 liter for every hour, per hour. So this, anywhere I see, if I see a number and the word per pretty close to one another, that's M every time. Okay, so I come down here and I now know what M is. M is going to be -1 because I'm losing 1 liter every hour. The only other thing to plug in here is the time, T. So there's your equation. L equals -1t plus 35. I start at 35 liters. I lose 1 liter every hour. Okay, does anybody have any questions? Okay, there's one other thing that it tells me here. Like part 2 here is asking me about how long is it going to take to have 19 liters left? When the bucket has 19 liters left in it, how many hours has the bucket been leaking? That's what we're after, right? It told me something about liters. Okay, we know where liters goes. Liters goes on the left because I labeled it L. Right? And so you're saying, okay, 19 equals -1t plus 35. And you say, okay, I'm after how long did this take? Well, that sounds like the time value. That's what I'm after. So you're just going to solve this. How do I get t by itself, right? Well, it looks like I have two different things here, as per usual. I have purple things, and then I have those magenta things, right? Or rods and single little squares. I'm going to try and group them together and then solve for whatever it is I'm looking for. One rod. What one rod is worth, right? So we're like, okay, create a zero pair, minus 35 with that. What you do to one side, you got to do to the other. And so you're going to go 19 minus 35 is equal to negative 1t. 19 minus 35 is going to be 16. I'm standing at 19, and I'm going to take away 35. That's going to be negative 16, right? The t is not yet by itself. There's still a negative 1 on it. So to get it by itself, you're going to divide by negative 1 on both sides, right? 16 divided by, or negative 16 divided by negative 1 is going to be 16 equals t. And then you can say with any word problem, therefore, it will take 16 hours for the bucket to have 19 liters in it. Any questions? I'm going to check. It's good, Brandon. Okay, good. Okay. These come down to identifying what's up, right? Like looking at the word problem and then identifying where you're gonna, like, what variables you're gonna use. That's your let statements, right? This stuff, which really doesn't matter. You can just set them to be whatever you want, as long as it makes sense to you. And then you identify where you're gonna, like, how is the question changing and where do you start, right? So for the next question, it looks like I'm starting at 70 liters, right? And I'm burning 0.14 liters per kilometer, right? And so you're going to say, okay, well, let's write an equation about the gas tank. Again, we could say let L be gas in tank, right? And then we could say, I don't know, let K represent distance driven. So you say, okay, I'm interested in the gas tank. How much is in the gas tank specifically? So L equals, where do I start? Oh, I start with 70 liters of gas in there. Okay, plus 70. How is it changing? Well, I'm burning, so I'm losing 0.14 liters. There's that word per. Okay. There's your equation, right? So that's step 1. Step 2 is how many kilometers can Bailey travel before the tank is empty again? Well, if the tank is empty, that means there's no gasoline in it. So you're going to say 0 equals negative 0.14 K plus 70, right? And we're going to say, okay, I'm going to create a zero pair here. What I do to one side, I got to do to the other. And so you're going to get negative 70 is equal to negative 0.14 K. How do I get K by itself? Divide both sides by negative 0.14. And K will equal 500 kilometers. Or 500. Right? And then you can say in your little statement, therefore, Bailey can drive 500 kilometers. Okay? I'm going to save number 3. It's the same thing. You're identifying how much money is in the bank account. That's your starting value. Or B, you're spending 5 minus 5 T or X or whatever. Right? 5 per day. Okay, does anybody have any questions?